In this tutorial, we're going to take a look at the cosine law, and I'm not going to prove it or derive it in this video. I have another video on my YouTube channel if you want to see a proof of the cosine law. So we're just going to state it here, show what it looks like to find sides, angles, and then take a look at some examples. So first of all, and this is just an arbitrary triangle. It does not have to be a right angle triangle. I'm going to talk about right angle triangles in a moment. It also works if it's a right angle triangle, but if you have a right angle triangle, then using right angle trigonometry is probably a little more efficient than using the cosine law, okay? Or Pythagoras' theorem if you want to find a side and you know two others. So that's what it looks like for side B. So b squared equals c squared plus a squared minus 2ac times the cos of b. Looks like there's a little bit of a space here. I didn't want to have my c and the cosine too close to that c, and someone might think it's a c cos. So there's actually an implied multiplication right here. So notice to find side B, I need to know sides A and C, and that's the two sides here that are squared here. And I need to know the angle across from the side I'm trying to find. So in the triangle, if this is my unknown side, then I need to know this, and I need to know the angle across from the side I'm trying to find. That's the information I need. So if I want to write it out for side A squared would equal b squared plus c squared minus 2bc cos A. Again, the same two. You need to know the two sides beside the one you're trying to find, and these two sides are the same ones that are here, and that angle is the one across from this one. And of course, for c squared equals a squared plus b squared minus 2ab cos c. Again, these are the two angles that are squared here, and this angle is the same as the one that's across from that one. Let's get rid of our writing here. Now, if you happen to have a right angle triangle, let's bring the calculator over here. So let's say we were using this version of the cosine law, and we didn't realize it was a right angle, although that might be kind of hard, because if angle C is 90, then it would probably be labeled. But anyway, let's say you didn't realize. So if angle C was 90 degrees, cos of 90 on the end here works out to be 0. So if that's 0, 0 times no matter what a and b and the negative 2 multiply to give you, this would all be 0. And the cosine law would actually just reduce to the Pythagorean theorem. We would get c squared equals a squared plus b squared. So it does still apply for right angle triangles, although again, if it's a right angle triangle, you might want to just use Pythagoras' theorem or some right angle trig. Okay, so it does work for right angle triangles. So now, in each of these cosine laws written here, there's the three sides and there's an angle. So if I knew, let's say, side A, side B, and side C, I could use this actually and solve to find the angle C. So if you know three sides, you can actually find any angle. See up here, if I wanted to find angle A, then I would use this version. So what I'm going to do next, before we get into some examples of using it, is if all three sides are known, the cosine law can be used to find any angle. So we're going to take this one here and solve it for cos C, but it's the same idea if you solve for cos A or cos B. It's very, very similar. You're just using a different one here. So we're going to solve this for C here. So I'm just going to rewrite that version of the cosine law. And if I'm going to rearrange it for cos C, what I'm going to do is I'm going to bring this expression over here to the left. And the reason I'm rearranging that way is because then this expression will actually become positive, and I want to also isolate the expression that has the cos C in it. So that's another reason to bring it over here. So I'm also going to bring the c squared to this side, and of course it'll be a minus c squared. And if you rearrange a little differently, say I'm actually adding 2ab cos C to both sides, and I'm subtracting c squared from both sides. So it will look like this. So that term will be positive on the left, and there'll be a squared plus b squared minus c squared over here. Now, we want to isolate the cos C, so I want to get rid of this 2ab here. So I'm going to divide both sides by 2ab. So on the left here, the 2ab's divide out. And then it looks like this. So we have just cos C on the left here, equals a squared plus b squared minus c squared over 2ab. Again, if you know the three sides, you can find any angle. So that's the cosine law, what it looks like for angles. Now, so notice the way, and again, just a pattern here, okay, to remember how to write it. Notice that if it's angle C I'm finding, I have cos C over here, then it's the c squared I'm subtracting on the end. So it's a squared plus b squared at the beginning, and it's 2 times, and these two sides are the same two ones that are squared here. So similarly, if I want to write it out for cos A, if I want to find angle A, then it's going to be b squared plus c squared minus a squared. Again, this is the side across from the angle I'm trying to find, and these two sides are the same two that are being squared here. So I want to write out for angle B, cos B would equal a squared plus c squared minus b squared. Again, the one that's subtracted squared on the end is the one across from the angle I'm trying to find, and these two sides are the same two that are squared up here. So you can use those, and there will be an example that will follow very shortly to find an angle using the cosine law. We use cosine law lots to find sides, but you can use it to find angles too. So first example here, in this example, Jillian wants to measure the distance across a small lake behind her house. And we're going to assume it's not winter, so she can't just walk across the lake. So we're going to assume it's liquid water here. So what she does is she finds 2 points across the lake. That's the distance she wants to find. And she measures to some point on the land. This is 175 meters, this is 160 meters, and that's a 71-degree angle. And so this is the scenario to find a side using the cosine law. You know the other two sides and the angle between them, or the angle across from the side we're trying to find. Now let's label the triangle. So I'm going to call it A, B, C here. So that would be side A we're trying to find. This would be side C over here. So little c is 175 and little b would be the 160 over here. And of course angle A is a 71. So this is the version of the cosine law I want to use because I'm trying to find the A side. So a squared equals b squared plus c squared minus 2bc cos A. So the next thing I would do is substitute the 160 in for side B, the 175 for side C, and the 71 degrees for angle A. So that's what it looks like. Now, we just have to square this, multiply this all together. I could bring my calculator over here, but I took a screenshot. So the 160 squared is 25,600. The 175 squared is 30,625. And this is all multiplied, so you just go 2 times 160 times 175 times cos 71 degrees. So that's what's right here. So it's about 18,231.8. So that's what my next line looks like. And now one caution here. Be careful of the signs. If this happens to be an angle that's bigger than 90 degrees, then you'll find that that angle will have a negative sign. And so that's a fairly common mistake when students start using the cosine law. If that's negative and this is negative, then you'll actually end up with a plus here, whatever this number is. Okay, so be careful if this angle ends up being bigger than 90 degrees. So this number plus 25,600 plus 30,625 minus this 18,000 number is 37,993.2, and then in order to solve for A, we take the square root of that. And so A works out to be 195. Maybe we'll bring the calculator just back here for a second. So square root of 37,993.2. So 194.9, so I'm rounding to the nearest whole meter because these are rounded to the nearest whole meter. So the lake is about 195 meters long. Example number 2. Now in this question it says solve the triangle, and solve the triangle means to find all unknown sides and angles. So we've got two sides here and the angle between them. So this first part's like the example on the previous page. This is the classic cosine law to find a side. You know, the other two sides, the angle across from the one you're finding, or the angle between the other two sides. So I would write out my cosine law for this triangle. And it looks like this. So side D squared would equal E squared plus F squared minus 2EF cos D. Again, that's the angle across them, the side we're trying to find. And so the next thing we would do is substitute in all the values. So E is 5.8, F is 6.3, and here as well. And the angle is 31 degrees. Okay, let's bring the calculator over here. And so 5.8 squared is 33.64. 6.3 squared is 39.69. And just multiply these all together. Cos 31. So it's the 33.64 plus the 39.69 minus the 62.64 number. So minus the 62 point, a couple dozen places would be good enough. So 10.69 in my PowerPoint. I guess I think I did keep a little more, so 10.688. That would round to 9. And then in order to find D, we would take the square root of that. So D works out to be about 3.3 kilometers. So that's the length of this side right here, 3.3 kilometers. Now, if we want to find angles, some angles, as soon as you start finding more than 3 sides and angles in a triangle, you get options. I actually could use the cosine law to find this side, or this angle, or this angle, or I could use the sine law. I'm going to do sine law here, just because it's a little bit quicker, but I will demonstrate the cosine law momentarily to find an angle. So I'm going to find angle E here. So sine E over E equals sine D over side D here, angle D on top, of course. So filling in the values, we're trying to find angle E. So side E is the 5.8 here. Side D is the 3.3 we just found, and angle D is the 31. So cross multiplying to find angle E, we go sine E would be the product of 5.8 and sine 31 divided by the 3.3. So maybe we'll bring the calculator back here. And so 5.8 sine 31 divided by 3.3. So 0.9052. So sine E will equal 0.9052 approximately. And so we take the inverse sine of that, and maybe we'll demonstrate that with the calculator too. So inverse sine 0.9052 works out to 64.85, so about 65 degrees. So angle E is 65 degrees. We'll put a 65 up there. So the most efficient way to find angle F is the fact that all 3 of these add to 180. So we can subtract these 2 from 180. So 180 minus 31 and 65 works out to 84. So this angle would be 84 degrees. And so that's all the sides and angles found in the triangle. In example 3 at the end here, so here's the one where we know all 3 sides and we want to find an angle. We don't know any angles yet. So if I want to find angle B here, I'll use that angle B, the cos B version from the first page of the tutorial. And so cos B would equal C squared plus D squared minus B squared over 2CD. Actually, I guess it's slightly different because we had it was the ABC triangle. This is a BCD triangle. But again, if I'm finding angle B, the B squared is the one subtracted on the end. And these are C squared plus D squared, and same 2 here that are squared up here. So we fill in all the values from the triangle, all the known values. And we'll evaluate the top up here, 0.3 squared. Actually, let's clear this so we just see what's being done in this question. Whoops, didn't get that. So that's going to be here, the 372.49 12.8 squared. So that's going to be 163.84. Now, if you're really good with your calculator, actually, I'm going to show this afterwards, I think. So that's going to be minus 462.25. And in the denominator, that's what it's going to be divided by, 494.08. So we'll see all those values, all four of these now. So we, of course, we just add and subtract here. We're going to divide by 494.08. And so that's what that works out. Now, before we find the angle, I do want to show, if you're really good with the calculator, you can do this. Okay, so from this step here, remember bed mass, I want to evaluate the whole top. So if I put brackets around that, I can do this. And this is the nice thing about having a calculator with an analytic display here, that we see everything that we're doing. Now I'm saying one thing and I'm typing two. I want to do this correct here, 0.5 squared. Close the brackets. So I'm going to evaluate the top, divided by, and in brackets the bottom, 2 times the 19.3 times the 12.8. Hopefully I typed everything right in there. So exactly 0.1499. There's the 0.11499. So if you're really good with the calculator, you can take this and evaluate it directly and get this one here. You don't really need to do all those. Although the nice thing about doing this is if somebody's marking an assignment or a quiz or a test or something, you are demonstrating all the steps. And you know, if all you do is maybe you forgot to square the 21.5, but you did everything else correct, well, you're probably going to get some marks for that, depending on who's marking your work. So to find the angle, we would take the inverse cosine of this 0.1499, and angle B works out to be about 81 degrees. And so that's how big angle B would be. Of course, if you want to find angle D or angle C, without even doing this, you could just use a different version of the cosine law for angles to find one of those. Or if we already knew the 81 degrees, you could do the same thing again to find angle D or angle C as well, or use the sine law. And that's the end of the tutorial.